Thank you guys for coming today. It is great to be back in person. I'm from Nashville, so it's always nice to have everybody come to me, and I only had to go 15 minutes to get here. I am Amy Greer from MOSIMTEC. We are a simulation consulting firm, so we really focus on everything related to simulation. We're not a A&E firm that does simulation on the side or a management consulting firm that does simulation on the side. We are simulation. MOSIMTEC was founded in 2011. We are an AnyLogic partner. As you can see, we work in a wide variety of industries: mining, warehousing, distribution, fast food. I've been using AnyLogic. I was trying to do the math last night. I think it was early 2005. Andre actually came to Nashville and trained us, and prior to AnyLogic, I'd been using Arena and AutoMod, and going through the AnyLogic training was like just big breath of fresh air. We really love how flexible it is. We love being able to do whatever we need to do in Java, and the run speed. We just haven't used any other tools that can really touch how fast we can get our AnyLogic models to run. On the schedule, Crouch Engineering was mentioned. I got a call from Scott yesterday. He actually is also local in Nashville, but he was on a plane to Boston. He had to go up to a client meeting. We had a little bit of miscommunication on schedule. But Scott and Crouch are also based here in Nashville. They are a railroad engineering firm, and they've been around for 32 years. We've partnered with them multiple times, particularly when they're doing some rail design projects where the rail interfaces with a tank farm or manufacturing facility, and they're really not quite sure how the rail will interact with the rest of the system. We are working on a project for U.S. Sugar. U.S. Sugar is the largest sugarcane producer in the United States, so there's a good chance you're going to eat something today that was handled by U.S. Sugar. I did not know this before I worked with them. They actually own their entire supply chain. They farm almost 250,000 acres in South Florida. They farm it, harvest it, transport it into the refinery, and then refine the sugar cane. When they do that transportation from field to refinery, it's all on rail, and they use something called cane cars. So you'll hear us say that cane cars a lot today. If you've ever been stuck at a railroad crossing, you've probably seen tankers or box cars. A cane car is just a specific type of car. It's got a specific specification and sizes that they use to bring the cane in from the field. It takes about 800 cane cars to operate this fleet. The refinery itself has 2 delivery points for the sugar cane. If you can see the red and blue squares, there's 2 rail lines that lead up to this point. The sugar cane is basically dumped into hoppers that feed the refinery. The sugar mill really has to be continuously fed. This is a continuous flow process. So if we shut down operations, if we starve the system of the sugar cane, there would be some pretty bad consequences in terms of restart cost. So this is a pretty continuous operation. When sugarcane is in season, when it's harvest, this runs 24/7. We always have to have trains staged and ready to go to keep the refinery fed. The cane cars were presenting a pretty unique challenge, mainly just because they're really old. They were 60 to 70 years old, a lot of maintenance costs as they broke down, but the Federal Railroad Administration also said they could not be used on public rail. I'm not quite sure what the deadline is, but it's very, very fast approaching. These cane cars cost $100,000, so to replace the entire fleet would be $80 million. Unfortunately, the sugar mill itself is sized for these cane cars. So unless we wanted to rebuild the entire refinery, we had to use cane cars, but the cane cars were going to be $80 million. So U.S. Sugar really, if you looked at that as their only 2 options, neither one of them were very attractive. So someone decided, is there a third option? Could we possibly use coal cars? There's a lot more coal cars available. They're affordable. Repair parts are readily available. The coal cars themselves are longer than the cane cars. They can hold more volume going from the field to the refinery. So coal cars sounded great until we get to the refinery, and then they don't work because the coal cars will not physically fit where the sugarcane is being dumped. That still had to be done by cane cars. So one of the ideas was, let's build a transfer system. We will use the coal cars to bring the product from the field to the refinery, and then we'll use a transfer system to get it into cane cars so it can get to the refinery. So my background's in industrial engineering. We don't normally like, multiple handling points. Having a transfer system is not really lean. But when one option is $80 million for cane cars or building a whole new refinery, all of a sudden looking at this extra transfer point looked pretty attractive. So just a quick animation to kind of give you guys an orientation of what the facility's like. This was a really small, quick model for us. I think it was only about a 3-week project. And so we did use the AnyLogic Cloud to deliver it. We just used a Google map in the background of what the facility looked like. But the green and blue lines up at the top of the screen, that's the existing facility. That's the cane cars coming in and feeding the sugar mill. The blue bars that are moving up and down, those are our hoppers. If those ever reach zero, the refinery would shut down. So you'll see we have this is like the beer training we did yesterday. We've got a little bit of buffer in there, but if those ever got empty, we'd be in trouble. Once those blue and green cars are dumped, they'll go off to the left. They'll go off to the left. Let me see if I can get that restarted. They'll go off to the left and then exit the system to the right. The multicolor trains in there are the coal cars that are coming in from the field. And you can see where they're dumping in a proposed dumper. The yellow lines are the empty cane cars that are being filled up. The coal cars and the cane cars, they don't have to be there at the same time. That's why we have the dumper. It gives us a little bit of a buffer if timing is different. One big point of concern was the track to the far left. Every single one of these train types was going to use that track. Once the cane cars were empty, they needed to use that track to go out and go back out to the staging area. The coal cars had to back up over that track to then hit a switch and exit the system. So everybody was going to use the piece of track to the far left. Oh, there's the coal car just went. So there was a lot of concern that if that track became the bottleneck, it would back up the entire system. So one of the alternatives was, let's build another track. There's a red line on this drawing. That's one of the alternative tracks that we were looking at. It definitely would give more capacity. We wouldn't have to worry about the trains being on the same section of track at the same time. So the railroad engineers knew that would give us more capacity. Unfortunately, that extra red track would be a $3 million expense. So U.S. Sugar wasn't too enthusiastic about spending an extra $3 million. Really, the key question for the simulation was, can this process occur with the minimal track? Do we absolutely have to build that extra length of red track? And why would we want to simulate this? As you guys saw, it's a pretty simple model. So while that might be a simple AnyLogic model, it'd be really hard to do in Excel. This is a process that has a lot of variability. We don't know exactly when the coal cars are going to show up. There's variability in our dumping time. So every time we bring a train over and we start to dump it, every car can take a little bit different amount of time. There's a lot of complex train moves of, well, this train's going to be here when that train's there, and we could put it all in a big Gantt chart, but because of variability, the Gantt chart would be wrong. So it was just really a system that they couldn't know for sure without a simulation which track alternative was going to work the best. We also simulate it because it's critical. If they went with the minimal track alternative and it didn't work, they could lose an entire season of harvest. When cane's in season, like we said, this runs 24/7. We had to make the right decision the first time. So a quick demo, like we said, this is a pretty fast project. We were able to use the AnyLogic Cloud. We used their user interface. We didn't put a custom interface around it. It enabled us to get some things out very, very quickly to US Sugar. They were getting POs ready. They really needed an answer. We were on a pretty tight timeline. So as far as inputs go, they could pick which track alternative they wanted. They could do a few crew constraints. Oh, let me get back. They could do a few crew constraints, change some processing times, but everybody was able to get in there and play around with the inputs. As far as the animation goes, this is what you guys saw earlier. US Sugar loved this. We deal with some models where we produce hundreds or thousands of outputs. We run dozens or hundreds of scenarios, hundreds of replications. They just really liked looking at the animation, and in this case, it was analytically helpful. They could see when there is a problem, what triggered that problem, what potentially operationally could we do to get around that problem. And then as you guys know from AnyLogic usage, there's lots of different stats that we can collect, and they could kind of watch on the animation as those went through. As far as the outputs go, like I said, they really like to watch the animation as kind of their primary way of judging if a solution was going to work or not. But it was really about starvation. If we saw any combination of inputs that starved the mill at any time, we knew that that just was not a viable alternative. So it was really nice. One project, one output, this is what we care about. But then we did have a lot of other leading metrics that we were looking at to help us understand how much slack we had in the system, if we were getting starvations, why were we getting starvations. What was interesting was when we did our first analysis and we ran the 2 track alternatives, we really didn't see a difference. And that was pretty shocking because everybody knew that that red track alternative, at least conceptually, was going to have more capacity. So it was pretty shocking that these 2 track alternatives, no difference whatsoever in performance. What we found was the new rotary dumper was throttling the system. So this is pretty common for us. The question was, is track 1 better than track 2? And the answer was, you need a new rotary dumper. I don't know that we would have found this without doing the simulation model. Like I said, they were talking to vendors. They had already sized their rotary dumpers. No pun intended, but the train had left the station. So they actually, with the simulation model, really found a critical design flaw that would have been really problematic. Once we did put in a secondary rotary dumper, which not only would give them capacity but help with downtime and maintenance, we did start to see that difference in the track performance that we were expecting. Some of the key benefits of using AnyLogic Cloud was definitely the rail library. We were able to iterate really quickly with the customer. I think it was like 3 days. We gave them a copy of the minimal track alternative. They watched it. They said, that's not quite right. Our trains don't move like that. So the rail library made it very fast for us to develop this tool. The AnyLogic Cloud also made it fast for us to iterate very, very quickly with the customer. We could have a call in the morning. We could often push out a change in the afternoon. They could look at it. They could play with different numbers. We had multiple stakeholders. The railroad engineers at Crouch were logging in. We had 3 or 4 participants at Crouch that were also logging in and looking at the model. The animation, as simple as it was, really opened their eyes to a lot of things. And it helped them with a pretty critical design decision. By the way, we thought at the beginning the question was track 1 or track 2. They've now gone back to the design board because of this model, and they are looking at a 3rd type of car alternative that would still fit in the refinery. So this simulation model really helped them avoid something that could have been a pretty costly decision. So that's all I have. I know, like I said, it was a short project, so pretty short presentation. But any questions you guys have?
Hi, stage center front row. Hello.
The light is very bright up here.
I know, right? So my name's Dylan. I'm originally from a farm. And so when you mentioned that if there's any delay in the trains, the sugarcane harvest gets wasted, an entire season can potentially get wasted. What makes sugarcane so, sorry, this is a very selfish question of me. What makes sugarcane so special in that downtime of this facility wastes the crop and not just the refinery time?
Yeah, I don't think it was that it would waste the crop. I think it was on the refinery. When you have the equipment that's a continuous flow equipment, if it gets shut down, a lot of times this big heavy equipment, when you're milling something, you start that back up. Things that were working fine don't work fine. So it's really more on the refinery. Like I said, if the refinery was getting shut down every 2 or 3 days because we had a blip in delivery, and then it takes 6 to 12 hours to start back up. So it really was on the refinery side of things that the entire season could go very, very poorly if we were starving the mill.
So a second question then, on that single piece of rail where things could fail, or I guess anywhere on that rail, did the model include maintenance, breakdowns, anything like that?
Not on the rail itself. We did talk about some of the cars or the locomotives having some maintenance and downtime. Crouch and U.S. Sugar, they weren't too concerned about that. One of the ways, like I said, we were going pretty fast on this model because they had a decision deadline. If they were going to do this before the next season, they needed to make some decisions very quickly. So we were looking at it more from the perspective of, if it did fail, what are their operational opportunities to do something about it. But I don't think anyone was really concerned about the rail itself, but potentially some locomotives and, making sure that they would have crews in position to deal with that.
Hello. Quick question. Did this model help you determine how many coal cars were needed for them to either lease or purchase? Because they were going to have to make, this coal to sugarcane car transfer?
Yeah, so that was definitely one of our inputs, was to look at the coal cars, also even the cane cars within that closed loop system. There was a staging area that wasn't shown on that animation. So both in terms of the coal cars and the cane cars, what those counts would be. It was definitely an input of the model. It was something we did experiment with a little bit. But like we've said, the rotary dumper kind of became the showstopper. So dealing with fine-tuning some of those other more detailed questions became a little bit of a back burner question.
Did you get to do a site visit for this project? And if so, did you learn anything cool while you were there?
No, I did not. I wish we did. So I've been doing simulation modeling for 19 years, and it's one of the best parts about doing this. If you're new to simulation, last year I think I saw an airplane manufacturer, a herbicide production facility, so chemicals. I've been on a cruise ship to study their galleys before. So no, we did want to go down and see it, but I think just given the tight timeline on this project, we weren't able to do that.
Anything else? Thanks, Amy.